So to calculate a complex circuit, the way I'm thinking about doing it is you just make a guess for one of the currents. So let me be clear. It's a 5 volt, 4 volt, 3 volt battery, a 1 ohm, and a 2 ohm for the heck of it. Sorry, you can barely see this. This is a resistor here. And I'm just curious what all the currents are. So what I'm thinking is you just make a guess for one of the currents. So I'm just always going to start with a guess of 0. So if 0 goes up this way, and let's just call this ground down here for the hell of it, we have 4 minus 0, so 4 volts up top, okay? And if that's true, let's see what the left-hand side would have to do. Well, to have 4 volts be this way, we must have a current, we'd have to lose some voltage going up through this resistor, so we must have 1 amp going up. But if 1 amp is coming in this way, and none are coming this way, we must have 1 amp going down over here on the right side. If that's true, we now have a problem, because if you follow the voltage here, start at 0, you gain 3, you'd gain another 2, that gets you to 5. So let's call our deficit what the original person says minus what the going up the middle minus going up the right. So 4 minus 5 is negative 1. Okay, so we have a deficit of negative 1, means there's a problem. Clearly our guess was wrong. Now let's guess 1 amp going up. If that's true, we'd have 3 at the top. And if we have 3 at the top, we must have 2 coming up this way over here on the left-hand side. And if I've got 2 coming this way and 1 coming this way, I must have 3 coming down this way. And if that's true, then coming up here I have plus 3 volts, plus another 6 volts, that's 9 volts. 3 minus 9, this 3 here, minus 9 is negative 6. So that means that our deficit got worse. And we need to go the other direction by about 1/5 of what we did before. So therefore, I think the correct answer is negative 0.2. Also known as 0.2 current coming down. Let's check what happens. The voltage at the top then would be 4 plus an additional 0.2, so that's 4.2 volts up top. What happens over here on the left-hand side? Well, to get to 4.2, we need to lose 0.8 coming up. So that's 0.8 amps coming up over here. And if I've got 0.2 down and 0.8 coming over here, it must mean I have 0.6 coming down over here. And let's see what our deficit is. So we've got 3 volts. Now let's see, 0.6 coming down, plus 1.2 is 4.2, but that's exactly what we thought we had was 4.2, so a deficit of 0. So here's all the currents for that circuit.